Okay, the following is a video over 3-9 notes, and this is about derivatives of logs and exponential functions. So derivatives of logarithmic and exponential functions. Okay. So what I first want to do is take a look at the derivatives of the natural log. Okay. And what I want to show you here, and I'll go ahead and zoom in on this a little bit, is that we're already given some rules here. Okay, if I take the derivative with respect to x of the natural log of x, then I just get the function 1 over x. Okay, and this is true when x is larger than 0. Okay, over here we have this definition where it says the derivative with respect to x of the natural log of the absolute value of x is equal to 1 over x, and that's when x can't equal 0. Okay, we'll talk more about that in class. But then I want to also show you that this definition here, ddx of the natural log of u of x is equal to u prime of x over u of x. Okay, and what I want to clarify here is that this is the chain rule. Okay, this is the chain rule. So let's take a look at just some quick examples here, and I'm going to kind of go through these pretty quick. There goes that bell again. Lunchtime. Lunch has been canceled due to lack of hustle. Okay, so let's just say that I have, I'm just going to create an example here. So let's make an example. Let's say that we have the function y is equal to, say, the natural log of, 2x squared plus 1, okay? What I have here, if I wanted to find my derivative, y, okay, well, the first thing I'm going to do, let me go through and erase this. What is going on? Why can I not erase? Okay. Well, I'm just going to go ahead and write it. So what I want to do first is use the chain rule here. Okay. I'm going to let this inside function be u. So if I let u equal 2x squared plus 1, then I can find my derivative of that, u prime, and that's just going to be 4x. Okay. So what I would do is I would rewrite this as y is equal to the natural log of u, and if I found my derivative, I'm going to write that down here, it's going to give me u prime divided by u. Okay, so what I want to do is substitute those values in, and I'm just going to get 4x then divided by 2x squared plus 1, and this is my derivative. Okay, so it's a pretty easy derivative, u prime over u. The derivative of the natural log of x is just 1 over x. So pretty easy to do, and we'll do some practice problems here in a minute. But let's talk about another rule. Okay, and this is the rule for an exponential function. Okay, so this is an exponential. So exponential function. Okay, so let's just look at an example here, and it says that if I were to take the derivative with respect to x of b to the x, then we get b to the x times the natural log of b. So let's just look at a quick example here. Let's just say that I have y equals the function 2 to the x. Well, if I wanted to find y prime, then I'm going to follow this rule here, and I'm going to get the same thing, 2 to the x times the natural log of 2. Okay, and this is my derivative. Now, we've seen something like this. We've seen something like, let's say you have y equals e to the x, okay? And we already know that if we find the derivative of that, we're just going to get e to the x, okay? We already have a rule for that. But let's take a look and use this rule here to try and show how we get that. So if I were to take the derivative of this, okay, I would get e to the x, and then I would multiply that by the natural log of e. Well, the natural log of e, folks, is just 1, so we're left with y prime is equal to just e to the x times 1, which is just e to the x. Okay, so it's not too bad if hopefully using this example here can help you remember how to use it over here. All right, let's take another look at another rule, and this is for just a log function. Okay, and let's just kind of look at something. Let me write an example out and follow this rule that we've got. So let's just say that y is equal to, say, log base 7 of x, okay? If I wanted to find the derivative of that, find y prime, then I'm just going to get 1 over x times the natural log of 7, okay? Let's look at another example. Let's say I have y equals log base, 13 of x. Then my derivative, y prime, is going to be 1 over x times the natural log of 13. Okay? And that's all we're going to do on that. All right, so these are just some simple rules. I do want to do the chain rule for this one. So I do want to introduce the chain rule for this. So the chain rule. So let's say I take d dx of, say, log base b of some function u, okay, then that's going to give me u prime over u times the natural log of b, okay? So that's also going to work in our favor if we come across something like that, okay? All right, let's take a look at some of these examples, okay? And we're going to be using multiple rules here. So I first want to take a look at number 10, and that's me taking the derivative of x squared times the natural log of x. And the first thing I want you to see here is that you are multiplying two functions, okay? This is a function, I'm going to call that u, and this is a function, I'm going to call this v. All right, so if u is equal to x squared, and v is equal to the natural log of x, then u prime is just equal to 2x, okay? And v prime is going to be equal to 1 over x, okay? So now what I can do is I can cross multiply and add, and so I end up getting that the derivative with respect to x of that function is going to be x squared times 1 over x plus 2x times the natural log of x, okay? And so as a result, x squared over x, that just simplifies out to, dear Lord. Okay, that simplifies out to just an x plus 2x times the natural log of x. Okay, and this is my derivative, all right? So, all right, let's take a look at another one. All right, now this one, let's take a look at number 12. Guys, when they don't have any parentheses in there inside this, go ahead and put them inside of here, okay? And what I want to do is take the derivative of this. So I want to use the rule, using the chain rule, and the rule that we have is that d dx of the natural log of u, some function, is equal to u prime over u. So this whole inside function is my u, okay? So I'm going to let u equal 2x to the 8th, okay? So then this means I'm taking the derivative of the natural log of u, which the derivative is going to just give me u prime over u, okay? Let me erase that part right there. Okay. So if I found u prime here, that's going to give me 16x to the 7th, okay? And so I'm going to substitute those values in, and I'm going to plug in for u prime, which is going to end up giving me 16x to the 7th, all over 2x to the 8th, okay? And so then, guys, this can be simplified. You can leave it like that, but let's simplify it. And if we simplify it, x to the 7th over x to the 8th gives us an x in our denominator, okay? And so as a result, in our numerator, 16 over 2 just gives us 8. So this is the derivative 8 over x, okay? So interesting stuff, interesting rules, all right? Let's take a look at the next one, number 56. And this is log base 10 of x. So if I wanted to calculate the derivative of this, so if I wanted to find y prime, I'm just going to use my rule and do 1 over x times the natural log of the base, which is 10. And that's it, folks. Okay? That's it. That's all we got to do. Follow the rule. Okay? All right. And I think, oh dear, we forgot number 24. Let's go to 24 real quick. I'm going to do number 64 in class. We'll talk about that in class. But this, in 24, I want to use my rule, okay, for the chain rule of an exponential function. And I don't know if I went over that too much, but let's go ahead and talk about that. Let's say I'm going to take the derivative with respect to x of some value, some number raised to a function, okay? And what that's going to give me is it's going to give me b to the u times the natural log of b times u prime, okay? So here I want to identify my u, my inside function, and that's going to be 3t. So if I let u equal 3 times t, then I'm going to rewrite my function as y equals 5 to the u power. Okay, if I found that derivative, if I found y prime, that's going to give me 5 to the u, all right, times the natural log of 5, all times u prime. Okay, well, u prime is just 3. Okay, and so if I plug everything back in, I'm going to get y prime is equal to 5 to the 3t power times the natural log of 5, all times 3. Okay, and that's my derivative. All right. So this should kind of give you a picture of what to do in this section. In this section, we'll talk about other stuff later on, but hopefully you enjoyed this video and it was informative, and I will see you guys later. Thank you.